Welcome to Homework Lib.
We want to take the derivative of a certain complicated function that is going to be, in this case, 3 plus 2x minus x squared elevated to the square root of x times 1 plus cosine to the minus 1 of x to the e divided by the logarithm of x plus 1 to the second of x. So in this case, to get this derivative, what we're going to do is substitute the different functions that we're going to have to make it easier on us, and then we're going to employ this method in which we're going to take the derivative with respect to x of this function g of x, and we're going to express g of x as the exponential of the logarithm of g of x. Okay, so first step is going to be to identify each of the elements. We're going to call it u, b, and w. So u is going to be equal to 3 plus 2x. Let me make more space over here. Actually, I'm going to use the whole scenario because it is going to be quite large. So u is going to be equal to 3 plus 2x minus x squared. ub is going to be equal to 1 plus cosine to the minus 1 of x. And w is going to be equal to logarithm of x plus 1. So now with this, our expression is going to be finding the derivative with respect to x of a different function, which now reads easier as u to the square root of x times ub to the e divided by w to the second of x. So now what we're going to do is take the logarithm of this function. So the logarithm of our function g is going to be equal to the logarithm of u to the square root of x times ub to the e divided by w to the second, of x. And applying laws of logarithms, this is nothing but logarithm of, well, actually let's do it in a single step. This is going to be directly square root of x times logarithm of u plus e times logarithm of ub minus second of x times logarithm of w. And now what we're going to do is substitute each of these ones by three variables a, b, and c. So now the logarithm of g is nothing but a plus b minus c. So now what is going to happen is that the derivative can be written down as the derivative with respect to x of our function is equal to the derivative with respect to x to the exponential to the logarithm of the function. And this simplifies as a plus b minus c, where a, b, and c are these big factors that we're going to have together. So now applying chain rule, this is going to be equal to exponential of a plus b minus c times the derivative with respect to x of the whole function of a plus b minus c. So this now becomes e to the, I'm going to write down a plus b minus c, and we're going to substitute at the very end, times the derivative with respect to x of a plus derivative with respect to x of b minus derivative with respect to x of c. So we're going to find each of these values. This is going to be quite a long process, so I'm going to try to make it as short as possible. So the derivative of a with respect to x is going to be equal to the derivative with respect to x of the function square root of x times the logarithm of 3 plus 2x minus x squared. This came from the substitution of u that we had above over here. And this is going to be equal to logarithm of 3 plus 2x minus x squared minus the factor that is 4x minus 1 times x divided by 3 plus 2x minus x squared. And all of this is going to be divided by 2 times the square root of x. Okay. We're going to do the same with the derivative with respect to b. So the derivative of b with respect to x. This is going to be equal to the derivative of b, which was e times the logarithm of ub, which was 1 plus cosine to the minus 1, of x. Recall that cosine to the minus 1 is going to be the arc cosine function. So in this case, this derivative of b with respect to x is going to be equal to e times minus e times the factor of 1 over square root of 1 minus x squared multiplied by 1 plus cosine to the minus 1 of x. And the final factor that we need to take into account is the partial derivative of c with respect to x, the derivative of c with respect to x, which is going to be the derivative with respect to x of c was equal to secant of x times the logarithm of w, which was logarithm of x plus 1, this derivative is going to give us, this will be secant of x multiplied by a variable factor, which corresponds to 1 over x plus x logarithm of x plus logarithm of x plus 1, logarithm of x plus 1 times the tangent of x. Okay, so now we have all three of the derivatives. We know what are the values of a, b, and c. So we can substitute, and we know finally that the derivative with respect to x of my original function is going to be equal to e to the a plus b minus c, which is exponential of a, which was this factor over here, the square root of x times the logarithm of 3 plus 2x minus x squared plus b, which was e times logarithm of 1 plus cosine to the minus 1 of x, minus c, so minus secant of x times the logarithm of x plus 1. And all of this is going to be multiplied by this factor over here, this derivative. So the first one is going to be logarithm of 3 plus 2x minus x squared minus 4 times x minus 1 times x over 3 plus 2x minus x squared divided by 2 times the square root of x plus the derivative of b with respect to x, which was minus e. So we need to put over here a minus e. Actually, let's put it directly as a fraction, right? On the denominator, we have 1 minus x squared times 1 plus cosine to the minus 1 of x. Over here, we're going to have an e, and minus the derivative of c with respect to x, which was the result that we got here. Secant of x multiplied by 1 over x plus x logarithm of x plus logarithm of the logarithm of x plus 1. Let me go a little bit more to the right. And all of this multiplied by this part multiplied by tangent of x, just as we had above. So with that, it would be all. This is going to be the final result for our derivative, all of this very big block that we got. Okay. So essentially that expression is the same as this one, but substituting the values accordingly to our equations.